Okay, today on the bench we have a radio chassis. Sorry folks, I don't have the rest of the radio. Customer sent this to me. He was going to recap it himself, and he decided, maybe not, I better send it out and get somebody to do it. So that's what I did. I replaced, there's actually, well, I guess you could say 3 electrolytic capacitors, but it's just a single multi-section can cap. That's been replaced. Actually, the can is still in there. I just put the new capacitors on the underside, and also replaced the selenium rectifier with a modern silicone diode, which I'll show that on the underside. Just wanted to show the top side. It's working. So this is a, like I say, it's a K731 Zenith, and uses a 7M07 chassis. So right now it's in FM mode. There, a little bit of Jimi Hendrix.
Prince George's County.
Okay, so there you can see she works. Like I say, this is an AM/FM radio. It's the cabinet. If you want to look it up online, it's actually, like I say, it's a tabletop versions, wooden. Nice receiving radios. They're nice. I think they look rather nice. Like I say, the customer wanted to just send this because, of course, it's a lot cheaper to just send this little chassis than it is to send the entire big tabletop cabinet that this thing goes in. So, and you already had it torn apart. Had the chassis out, so that was fine. Really don't need anything external other than, hook up a FM antenna, and the AM loop antenna is actually still attached here. And a speaker, and for speakers I was just running off my little speaker box right there. So, let me pause this. I'll get the power unhooked from it, and we'll get her flipped over so you can see the underside. Okay, so here we are on the underside. As you can see, not a lot to it. If you hear any booming in the background, in the middle of a big thunderstorm at the moment. So, good time I went ahead and unplugged everything. But, like I say, not a lot to them. There's not a lot of capacitors that need to be replaced. See, I replaced this one, and this one. In some of these 7M07 chassis, you'll sometimes find this one is a tubular style. So here's actually the old parts. Let me set this up over here. Just dump this out. Here's the selenium rectifier, but there's the 3 caps that were replaced. Now, sometimes you'll see, one like this, or the Bumblebee style, or the Black Beauty. In here, this one already had an epoxy dip one, so there's no reason to replace that. That one will be just fine, that film cap. Like I say, the electrolytic can cap is now completely disconnected. Just trimmed the leads off of the bottom of that, and installed 3 new electrolytics on the underside here. Just used 2 terminal strips. I had a little bit of extra room since I replaced the selenium rectifier right here that used to be mounted right here to that screw hole. So, like I say, it gives me a little bit of extra room, and I can easily just pop in, terminal strips. That way, from the top side, still looks original. You'd literally have to remove the radio out of the the chassis out of the radio housing to see that it's ever really had anything done to it. Now, one thing when you replace selenium rectifiers with, so to give you an idea, I replaced this with that tiny little black speck. I don't know if you can see it. Right there. That's the diode. Okay? Right on top of my pointer. That replaced that. So, it's a good idea to replace these. Now, this one may have hummed along just fine for the next 50 years, but they're known for being problem childs. there's a lot of plates in here, and my understanding is it's not that the selenium part of it goes bad, it's that because it's multi-sectioned, you can end up with oxidation, corrosion, or whatever happens between the sections. It ends up causing high resistance, and eventually they just overheat and burn up. So it's a good idea to replace these. Now, if you do ever replace a selenium rectifier, just be aware you can't just go slapping in a normal, like right there, a normal silicon diode modern replacement and expect it to work okay, because your radio might just go up in smoke. Or at least you'd do a little bit of damage to it or shorten the life of components, especially tubes. The reason is selenium rectifiers, you gotta remember, this is kind of like a heat sink. That's why they kind of look like that for starters. These things dissipate a good bit of power. They have a rather large voltage drop when compared to modern silicon diodes. So when you replace a selenium rectifier with a modern silicone rectifier or diode, you need to add some additional resistance in series with it. Now this was the original dropping resistor for this one. AC, 120 volts came in here. Half-wave rectifier basically comes out the other side, and this, at this point here, that went to the filter cap, which is now that one right there, and that supplies the B positive for the entire radio. So there's not much to the rectification circuit in these radios. But like I said, just something to be aware of. Anytime you replace one of these, you're always going to need to add some additional resistance. It's not hard to do, especially if you bring your radio up on a Variac power supply. You stick your new diode in, stick in something that you think might be about right, and then slowly bring it up on a variable power supply, and just clip your DC voltmeter on here, in your new circuit here, so after your dropping resistor, and check the voltage. If you see that it's starting to get too high, you need to add a little bit of additional resistance. So in this case, there's actually two now. These two big 3-watt ones in here in series. So it comes through the silicone diode, through this resistor, out this resistor, and over to positive for the main filter cap right there. So, like I say, not a lot to it. Now, a word of caution to anyone who works on old radios, and especially this chassis. This is a death-in-a-box chassis. If you notice, there's these nifty little plastic critters on here. That's so that you cannot get electrocuted from outside, from the exterior of the radio. It protects the owners or operator of the radio. This is what is known as a live chassis. So here is your power inlet right here. This is what the power cord plugs into. Okay, so we have a brown wire. That's what comes around. You follow that. Get the camera back down here. Follow that brown wire that comes into right here, one side of the diode that I installed. Comes through that diode, through the resistors, and then that's your high voltage once it goes through the diode. And then also all of the tubes in this are in series, the filaments. So the filaments are directly heated off the 120 volt AC line. But that's not the problem. That's not what makes this what I call an unsafe or a live chassis. If you follow the other wire, the black wire, you see that comes along here, loops down underneath, comes up, goes to the on-off switch volume control, and there's the out. And where does that go? Solid metal wire comes straight down to the chassis. Straight down to this metal chassis. So that means this chassis can be at 120 volts. And I say can be, actually pull the power cord here, because back in the day we did not have polarized plugs. So if you notice, both sides of this plug are the same width. If you look at your modern wall outlets, you'll often notice that one pin is wider than the other one. Actually, if you look up even at my isolation transformer power supply here, you'll notice one pin is larger than the other pin. Okay? Now, in that, the small or narrow pin on those is the hot. Okay? So if you were to walk over to your house outlet, hook up a voltmeter between here and ground, you should read somewhere between 110 and 120 volts. You go between the large wide one in here, there won't be anything, because this is your neutral. And your breaker panel or fuse panel, that just ends up going back to your ground bus. But like I say, back then we didn't have polarized plugs. So you have a 50-50 chance when you plug this cord in. You might have the chassis going to neutral, like this, but if you plug it in this direction, your chassis is now at 120 volts. Now the radio doesn't care, it can operate either way, because it's AC going into it, it's alternating current. And like I say, to the owner, it doesn't really matter. Everything that the owner could possibly touch on the outside of the radio is isolated. Now these aren't the original knobs. I just stuck these on there so I had something to use while I was working on it. But the knobs are plastic, so you can't get electrocuted through there. You can't get the screws that hold the chassis into the radio cabinet. They may be metal, but they are attached with plastic, so that isolates the chassis from the screws. So even if you were to touch the underside of the radio and touch those screws, you can't get electrocuted there. So it's just that the technician or somebody working on one of these needs to know that you really need to watch it so you don't get electrocuted, because you might stick your finger on here, and depending how you have that plugged in, you could be hooked up to your neutral in your outlet or the 120 volts. And we can show that to you on a schematic here. There's a 120 volt plug. If we follow one wire up, you can see there's your filaments, all filaments for all the vacuum tubes. But if we follow that up, came to that original, that selenium rectifier right here, which is now a silicone diode. There was that original dropping resistor right there. That comes over filter cap and then goes out to supply high voltage for the radio. So that one's not the important one. We want to look at is the other one. So that comes in, that was that black wire. That comes up, goes straight to, what is that? Aha, that's the on-off switch. And what does that go to? Chassis ground. So, like I say, really need to be careful there. Really good way to get zapped. Depending how you have this plugged in, you might have 120 volts at the chassis, or you might have your neutral. So it's just something to be aware of when you're working on it. And that's why anytime you work on old radios, you want to have an isolation transformer. Now this one is also a variable power supply, but the main thing here is it's an isolation transformer. So that way I can touch this chassis, I can have 120 volts going through my body, and as long as I don't touch something else in the same radio, I don't have to worry about getting electrocuted. So I can touch my test equipment that's grounded to the ground coming out of my outlets, and I won't get electrocuted, because after you go through that isolation transformer, it's basically 120 volts. It's a floating voltage, so it has no ground reference. But you still need to use caution. Like I say, you can still touch the chassis with one finger and touch something else in here with the other finger and still get electrocuted, because there still is 120 volts. It has reference to itself within the chassis, but as far as your ground in your house or on your bench, you're isolated. So just be aware of that. So there you go, there's just a quick video on a Zenith chassis, a few things to watch out for, a few tips. Like I say, if you're replacing selenium rectifiers, which is a good idea, just be aware you need to usually increase the size of any dropping resistors. You'll need to add some resistance so you don't overpower your B plus line. So there you go, that's pretty much all there is to it. I hope someone can find some of that information useful.